Chapter 5, Section 1, Rate of Change and Slope. A rate of change shows the relationship between two changing values. We're going to show that relationship by putting the change in the dependent variable over the change in the independent variable. This is going to be very similar to slope. We're just calling them dependent and independent variables instead of x and y, which we will talk about here in just a second. The table shows the elevation of a hanging glider over time. Is the rate of change in elevation with respect to time constant? And what does the rate of change represent? The first question that it asks is the rate of change constant? We've talked about this before. Remember, constant means that it's changing at the same rate each time that it changes. So if you look down the time column, notice that each time we go down to go from 1 to 2, you add 1, 2 to 3, you add 1, and 3 to 4, we add 1. So the rate of change in time is constant. And then we're going to look at the next column, which is the elevation in feet. If you look to go from 360 to 325, we subtract 35. To go from 325 to 290, again you subtract 35, and you're going to subtract 35 again. So is this elevation constant? Yes, it is. As the time is increasing by 1, the elevation is decreasing by 35. Then it asks, what does the rate of change represent? First, let's write our rate of change. Remember, we just said it is the dependent variable, the change in the dependent variable over the change in the independent variable. If we are given time and elevation, our independent variable would be time, and our dependent variable would be elevation. So to write the ratio for the rate of change, we're going to write negative 35 over 1. And anytime you have negative 35 or a number over 1, you can write it as a whole number, but for this, I'm just going to keep it like this for this example. This asks, what does the rate of change represent? So what does negative 35 over 1 represent? What it represents is the elevation of the hang glider is decreasing, because it's a negative 35, by 35 feet every minute that goes by. So for every minute that has passed, the hang glider is, their elevation is decreasing by 35 feet. When we talk about slope, first of all, when we talk about slope, we're talking about a graph of a line. It says slopes can be descending or ascending. A descending slope means that it is negative. It also means that it would be going down as you look at the graph from left to right. An ascending slope, on the other hand, is going to be positive, and it is going to be going up as you look at the graph from left to right. So you're going to look at these graphs as if you were like reading this slide, for instance. You're going to start at the left and go to the right. If the line is sloping up, it would be positive or ascending. If this line is sloping down, it would be negative or descending. To find the slope when we're given a graph of a line, first of all, the slope is a ratio of rise over run. And I think everybody in this class should have heard rise over run before. When you're finding the slope and you are given a graph of a line, you're going to count slope from one ordered pair to the next on the graph. The rise is going to be how far up or down you go to get from one point to the next. If you're going up, it would be a positive. If you have to go down to get to the next point, it would be a negative rise. And the run is how far to the right or to the left you go. Again, if you're moving in the right direction, if you have to go right, that would be a positive run. If you have to go to the left, that would be a negative run. This example asks us to find the slope. Notice I have points on the line, and you can choose any 2 points. I say choose consecutive points. That means the points that are right next to each other on the line. So for this example, I'm going to choose this point. This would be an ascending slope. I'm going to choose to go up from the point at 1, 0. So my rise would be a positive 1 because I'm moving up. And then to get to the next point on my graph, I need to go to the right one space. And again, that would be in the positive direction, which means the slope would be at 1 over 1. Anytime you can write slope as a whole number, go ahead and do that. So instead of writing 1 over 1, we're just going to write 1. This slope, again, as you look at it from left to right, would be an ascending slope because it is increasing from left to right. Choose 2 points on the graph. Again, I say consecutive or right next to each other. And count your rise over your run. So in this case, I need to go up 2 units, and I need to go to the right 1 unit, which means my slope would be 2 over 1. Again, I can write 2 over 1 as the whole number 2. So in this case, I have an ascending slope of 2. Notice both of the lines that have had an ascending slope have had positive slopes. And that is always going to be true. If it's ascending, it's going to have a positive slope. If you look at this example, though, notice as we go from left to right, would be going down, which means it is a descending slope. Choose 2 consecutive points. You're going to have to go, if I choose these 2 points, the one on the y-axis and then the one to the right of it, I have to go down 1, which means that my rise would be a negative 1. And then I have to go to the right 5, which means I would have a positive 1, or a positive 5. So my slope is going to be negative 1 over 5. Something that I really quickly want to point out is it would have been possible if I would have chosen to start at the point on the far right and go to the point that's on the y-axis. I would have had to go up 1, so that would be a positive 1, and then to the left 5, which would make it a negative 5. That is the same exact thing as having a negative 1 over 5. As long as you have a negative either on the top or on the bottom number, then that would be considered the same slope. If you look at this line, it is a horizontal line. If you think about rise, our slope is rise over run. If you think about moving up or down from a point on that line, if I move up or down at all from one point, there's no way that I can get back to the line. So in this case, my rise would be 0, and your run can actually be any number, because if you move to the right 3 spaces, you're still going to be on the line. If you move to the left 3 spaces, you're going to be on the line. Even if you move to the right like 25 times, you're still going to be on the line. Because remember, lines go on and on and on forever. That's why we have the arrowheads on them. If you look at the slope, I wrote 0 over 3. You could have 0 over any number. If you think of this as a division problem, think about 0 divided by 3. And 0 divided by anything is always going to be 0. Any horizontal line is going to have a slope of 0. Sometimes people call them 0 lines. That means that it's a line that has 0 for a slope. This next example is a vertical line. If you notice on this one, I can rise, again, just like I could run on the last example, any number. I could rise any number, and I could go up any number of spaces and go down any number of spaces on this line. But if I move to the left or right at all, I'm going to be off of the line. So in this case, I chose 3 again. Your rise would be 3 over your run is 0. You cannot move left or right and get back to the line. If you remember, we cannot divide by 0. 0 cannot go into any number. What we say when we're trying to divide by 0 is that it is undefined. So any vertical line, just like with any horizontal line, it had a slope of 0. Any vertical line is going to have a slope that is undefined. Finding slope when you're given 2 points. To find the slope given 2 points, you can use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What the sub 2's and the sub 1's are the 2's and the 1's that you see. We're not multiplying anything by 2. We're not dividing anything by 2. That's not an operation that is happening to the y's and the x's. What those sub 2's tell us is that the y sub 2 and the x sub 2 are from the same ordered pair. So these are the x and y values from one ordered pair. And then the y sub 1 and the x sub 1 are the x and y values from the other ordered pair. So when we're given two ordered pairs, we're going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it's very important that whatever ordered pair you take from first to get your y, you take that x value to put first on the bottom. An example of this says, what is the slope of the line through f at negative 3, 2 and through g at 1, 5? There are two valid ways to use the formula that we just learned. One way would be to say 2 minus 5. Notice that's my y value from f minus my y value from g over negative 3 minus 1. Notice 2 is on top first and negative 3 is on bottom first because they both come from the point f. And then notice that I'm subtracting 5 second on top and I'm subtracting 1 second on bottom because they both come from point G. When I subtract these, you get 2 minus 5 is negative 3 over negative 4. If you think about, we don't need to make this a decimal. We want to keep our slope as fractions. If you have a negative over a negative, though, that's going to be the same as a positive. So negative 3 over negative 4 as a slope is the same as a positive 3 over a positive 4. Now I said there are two different ways that you could write this, use the equation correctly. The other way would be to have 5 minus 2, notice those are my two y values, over 1 minus negative 3, those are my two x values. In this case, I've taken point G and I've put their y and x first, and then I've subtracted my x and y from point F. If you do this operation, you have 5 minus 2, which is 3, over my 1 minus negative 3. Remember, double negative is the same as plus a positive, so 1 plus 3 is 4. Notice either way that I did this, I got the same slope, positive 3 over 4. Now, if you flipped the order any other way than these two, then you would not end up with the correct slope because you didn't keep your ordered pairs in order. The next example says, what is the slope of the line through F at 50, 0 and G at 32, 6? Again, there's going to be two valid ways to do this. I'm just going to show you one on this example. You're going to take your x or your y values and subtract them. I chose to do 0 minus 6. Because I chose 0 first for the y's, I need to choose 50 first for the bottom x's. So I have 0 minus 6 over 50, because it came from the same ordered pair as 0, minus 32, because it came from the same ordered pair as 6. When I subtract these, I get negative 6 over 18. When you can, this is going to stay negative because there's just one negative. But if you notice, 6 over 18 can be simplified. 6 can go into both 6 and 18. So I do want to go ahead and simplify it and write this as negative 1 over 3. If you did this the other correct way, it would have been 6 minus 0 over 32 minus 50. You would have ended up with 6 over negative 18, so then you would have ended up, when you simplified it, with 1 over negative 3. That is going to be the same thing as negative 1 over 3 when we're talking about slopes. Today's assignment is on page 317, numbers 2 through 32 even, 41 and 42.